If you haven't taken the time to read the question, please read the stem of the question and then read both parts A and B before you watch the rest of the video. Please pause the video and then start it again after you've read it. This question then is about songs played on the radio. So we are looking at song lengths, where in minutes, if you look at the distribution of those lengths of the songs in terms of minutes, the distribution is roughly symmetric. So it's not really crazily skewed one way or the other. So we have a mean song length of 3.9 minutes and a standard deviation of 1.1 minutes. So your job is to use that information to describe the sampling distribution of the sample mean song lengths. That's important. And then you have a sample size. The sample size is 40. So don't just write the distribution. It's important that you describe what you are doing. So I already know that the samples are random. I know that the samples are random. So I know that the shape is approximately normally distributed because of the central limit theorem. 40 exceeds 30 or more. So again, the population is not normal, but that's okay. Because of the central limit theorem and our sample size being 30 or more, I know that the shape is approximately, so I can say that X bar is distributed approximately that word approximately is very important. So remember, your job is to describe the shape. Your job is to describe the center and the spread. So it's important here that you take the time to write about how the normality condition is met. The normality condition. So again, I would offer you should write about the central limit theorem and the sample size. But also, in order to use that standard deviation, we have to believe that the song lengths are approximately independent from song to song. So you should also be writing about the independence condition here. You could also think about that as the 10% rule. So the nice part is I already know that I have random samples of songs. So to describe the sampling distribution, it's not enough just to give the shape, the center, and the spread. This word is important, but then you also need to explain how the conditions are met here to justify that sampling distribution. So you should be writing at least briefly about those two. So then finally in part B, you have an actual probability to calculate. So we have 80 minutes of news and advertisements for a 4-hour or 240-minute show, so only 160 minutes then are available for music. So approximately, what's the probability that the total amount of time needed to play 40 randomly selected songs will exceed the available time? So I'm calculating a probability. So this probability is about a total. So I'm going to write this as total time. And I'm concerned about that total time exceeding, so that total time being greater than what's available. So what's available is right here, only 160 minutes. Now, I don't know the distribution of total time, but in part A, we've already written about the distribution of the means, the sample means for 40 randomly selected songs. So this is a question that you should convert into a question about a mean. So we are looking at a total of 40 songs. If I take my total time and divide by 40, I can turn this into a question about a sample mean. What's the probability that my sample mean exceeds this value? And that's a probability that you should be able to calculate using the sampling distribution that you justified in part A, your shape, your center, and your spread. So again, this is a question where you should end up converting this question into a z-score, and you can use the normal CDF, or you can use the shade norm command in order to find your final probability.